for P, the figure is a square. Okay? Q, the figure is a quad, I apologize for my sloppy handwriting, is a quadrilateral. I'm trying to leave a little room over here. All right. So what's the conditional statement? So let's start there. So the conditional statement, P implies Q. How do I write that? Yeah.
If the figure is a square.
Okay, so if the figure is a square,
then it's a quadrilateral.
It's a quad. Why didn't they pick a shorter word? Quadrilateral. Does that look good? Do you guys concur? Okay, you ready? Let's do the converse. So the converse was what? What do I write for the symbol for the converse? So this is, let's label this. This is conditional. Is it Q implies P?
Yes.
So that's the converse, right? All right, so how do I write that down?
In what form?
If the figure is
Wait, I
a
thought
square,
Converse was the same.
Wait,
If
Like
you
if
use
they're
quadrilateral.
both equal to.
Yeah, so you flip-flop it. So it's if, you guys are right, if the figure, and I'm going to abbreviate, if the figure is a quad, I'm just going to abbreviate a little bit, then what? It's a square. Right? Now realize that, and this is rigged up, you got to be careful because if you tried to make these up on your own, you'd run into a little bit of an issue. But the first statement, the conditional statement was what? True, right?
Yeah.
True. And now what about this one?
Nope.
Yeah, it may or may not be true, right? Like, does that make sense?
Sometimes true.
Yeah. So so you can't prove that it's true based on the way that it is. All right. So now let's do the inverse. And how do we do that? That was not P, not Q, right? So now how do I write that? If the figure is not a square, then it is not a quadrilateral. Now here again, we can't necessarily prove that to be true, right? I could have a rectangle, right? I could have a rhombus. Those are not squares, but they are quadrilaterals. So the way this is set up, you can't really prove a whole lot. So let's what we're trying to do is find the equivalencies between all these statements. So the last one we want to do is the contrapositive. So that was the combo of the inverse and the converse. So it's not Q implies not P, and that's what we call the contrapositive. All right, so if the figure is not a quad, then it is not a square. Now, can you see how if the first statement is true, if the conditional statement is true, do you see how that is equivalent to the contrapositive? Does that make sense?
Yeah.
Okay. Good, 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 good.
Are the inverse and are the conditional and contrapositive always going to be correct, and then the converse and inverse always going to be incorrect?
Well, they're going to have equivalencies. So if for example, let's say I wrote out that conditional statement and that conditional statement was false, then the contrapositive would be false as well.
So for the conditional, if you're saying if the figure is a square, then it is a quadrilateral, then how is that the same thing as contrapositive?
Well, what we're saying, we're taking the negation of one and proving it to be true. So in the first conditional statement, we're saying if it's a square, which we all know is a quadrilateral, but if it is a square, then it is a quadrilateral. That statement's true. Well, if it is not a square, or if it is not a quadrilateral, right? Quadrilateral is a four-sided figure with, based on the definition. We'll get into the definition later. But if it's not we know that a square is a quadrilateral. So if whatever figure you have, if it's not a quadrilateral, then we can be assured that it's not a square. Does that make sense? So we're saying the same statement from a truth perspective, right? So those two statements, although worded differently, the conditional and the contrapositive, we're wording it completely different, changing the order of it, but they're saying the exact same thing, except one is saying that if it is a square, then it's a quadrilateral, which is really the same as saying if it is not a quadrilateral, then it's not a square, right? That's like I say, if I walk outside and it's raining, I'll get wet. But if I go outside and I'm not wet, then it's not raining. See how they're saying the same thing, sort of?
But in a different way.
Yeah, but in a different way. So that's the relationship between the conditional statement and the contrapositive.